Hello students, welcome to video lesson 8.4. In this video, we're going to talk about one particular real-world application of trig ratios and one thing, or one context where the trig ratios are not only useful, but they are required to answer questions, to solve problems, to find unknown information, okay? And that application is something called angles of elevation and angles of depression, okay? So angles of elevation, angles of depression, they are real world angles from one thing to another. And we're gonna look at them in a lot of contexts in your practice problems. Today specifically, we're just gonna use them for indirect measurement, okay? And indirect measurement means I'm going to measure something, I'm going to discover the length of something or the distance of something without actually taking out a tape measure, okay? So we call it indirect measurement. We have a way to do it with angles of elevation and depression and trig ratios, okay? So we'll start with angles of elevation, and then you'll notice angles of depression is very much similar, but just sort of the other direction, okay? So if a person or an object is below another person or object, looking up at that person or object creates an angle of elevation. Okay, and the angle of elevation is measured from a horizontal line and the line of sight up to whatever that thing is that you're looking at up above you. Okay, so you could be looking up at the sun, you could be looking up at the top of a tree, you could be looking up at an airplane, you could be looking up at anything. Okay, anytime you look up at something that is above you, you are creating with your line of eyesight an angle of elevation, okay? So an angle of elevation, here's an example for you, okay? Here's a person standing on the ground. They're looking up at the top of a tree. They are creating an angle of elevation by looking up, okay? So the angle at which they look up from a horizontal line in front of them to their line of sight to the top of that tree creates what we call an angle of elevation. Okay, an angle of depression is exactly the opposite. If a person or object is above some other person or object, and the one that's above is looking down toward the person or object, should say below them, creates an angle of depression, okay? The angle of depression is still measured by a horizontal line straight out in front of that person and the line of sight down to whatever it is that's below them, okay? So for example, here is a person in a hot air balloon looking down at a person standing on the ground. They are looking down from the hot air balloon, so they create an angle of depression with their line of eyesight that looks down at the person below them, okay? So the angle of depression is looking down. Of course, if I were to take the person that's below the hot air balloon, and I were to draw a horizontal line from their eyesight, they can create an angle of elevation, right? This would be an angle of elevation because it's from, right? It's a horizontal line straight out from the person who's below and they're looking up. So this is an angle of elevation. Now, of course, these are both horizontal lines, right? So they're parallel, which means angles of depression and angles of elevation between two objects are identical, okay? It's always the same. So if I told you that the angle of depression from the hot air balloon down to this person measured, let's say, 17 degrees, then that means the angle of elevation from the person on the ground up to the hot air balloon is also 17 degrees, okay? So they're always equal because of alternate interior angles, something from way back at the beginning of our class together, okay? Now, when we are given these angles of elevation and depression, we can easily create right triangles and then use our sines, cosines, and tangents to find missing information, okay? So here's an example for you. If I'm going to just take that and get rid of that. And if I just do this, and I do this, right? Just by dropping that vertical line down, I have created a right triangle, okay? One thing I want you to notice in this right triangle, here's my 90-degree angle, the straight line distance of eyesight between these two people is my hypotenuse. right? So the straight line distance from one person to the other is the hypotenuse. The horizontal distance, like across the ground, like how far apart are these people horizontally, would be this side right here, right? This would be the horizontal distance. And then this is the vertical distance. So like how far vertical, how far above this person is that hot air balloon, right? Is it 10 feet above them? Is it 100 feet above them? Is it 6,000 feet above them? That's the vertical distance, okay? So the vertical distance and the horizontal distance are the two that meet at the 90-degree angle. The hypotenuse of the triangle is the straight line distance, okay? Straight line from one person to the other distance by the eyesight, okay? So we're going to go through a couple of example problems, word problems that give you context and ask you to solve for some missing information using these angles of elevation, angles of depression, and your sine, cosine, tangent, okay? So here's an example. James has hiked down a steep peak to the edge of a river, and his mother is standing up on the bank. The angle of depression as his mother looks down at him is 35 degrees. Okay, so let's just get in our minds what we know is happening. Okay, here's James's mother. This is James's mother. There's her big giant eyeball. There's her worried look of, oh, what's happening to my child? And she is going to look down at James, right? That was maybe a little bit steep. Let's go back. She's going to look down at James from a horizontal line. By the way, this is what I would suggest you guys do when you're doing these problems, is draw yourself a picture like this, okay? So then down here, we have James, right? Here's James. He's down on the edge of the river, just having a grand old time, just loving life. You know, and here's the river flowing deep and wide and all that stuff, okay? So we know from the problem that the angle of depression that his mother looks down at him with is 35 degrees, measures 35 degrees. So this is 35 degrees, okay? Now, if I draw a vertical line here, I then create a right triangle, right? And I create a right triangle. This is my 90-degree angle, this is 35 degrees. The question, according to this example problem, is this. If James is 22 feet below his mother in elevation, so this is 22 feet, what is the straight line distance between these two people? How far apart are they in a straight line by their eyeballs, okay, by their eyesight? So this is what I'm looking for. Right, now I'm going to take this and I'm going to draw it in a slightly different context, right? Basically, without the picture, I'm going to draw a right triangle where this is a 35-degree angle, that's a 90-degree angle, this is 22, and this is x. This problem should look exactly like what we've been doing in section 8.3, right? This is a problem where we're going to set up a sine, cosine, or tangent fraction, and we're going to solve for x. So what I want you to notice is for the 35-degree angle, I know the length of the opposite side, right? It's the opposite leg. It's 22 feet. I'm looking for the straight line distance, which is the hypotenuse. So I know the opposite. I'm looking for the hypotenuse, right? So this is O and H, opposite and hypotenuse. According to SOHCAHTOA, SOH, sine goes with opposite and hypotenuse, right? So I set up this little equation. The sine of 35 is equal to 22 over x. And now remember from the last video, I said my strategy generally is to turn the sine of 35 into a decimal. Okay, sine of 35 is 0.57357. So this is 0.5736 about, equal to 22 over x, and then I put that decimal over 1 and I solve a proportion. Okay, I use the fish method. You can do cross multiplication or whatever strategy you want to solve this proportion. 22 times 1 gets divided by the decimal. Okay, so 22 times 1, which is just 22, divided by 0.5736. That's going to give me x. 22 divided by that answer, 38.5 0.3558. Okay, so about 35.36. X, in this case, is equal to 38.356 about. Okay, and that's in feet. So I found that distance by drawing myself a picture with an angle of depression, setting up sine, cosine, tangent, and solving. Okay, one more example. In this case, we're going to actually use tangent. Okay, I will tell you that right now. And this one uses an angle of elevation. It says Timmy is looking up at the top of the flagpole at his school. The angle of elevation from Timmy to the top of the flagpole is 54 degrees. So I have a flagpole, a little bit thicker. I have a flagpole here, and then at the top there's one of those giant ball things, and then of course we've got our flag up at the top. All right. All right, there's our flag. And Timmy is over here, and he's looking up at the top of that flagpole. Okay, so here's Timmy. He's looking up to the top of the flagpole, and we are told that the angle of elevation from a horizontal line at Timmy's eyeballs up to the top of the flagpole measures 54 degrees. Okay, and then we are also told that the flagpole is 30 feet high. And the question is, how far is Timmy from the bottom of the flagpole? Okay, so when we draw our picture here, we do have to be careful of one thing. The thing is, the flagpole is 30 feet high, right? But the angle of elevation from Timmy to the top of the flagpole is, we're using his eyeballs, right? So here's the problem. If I extend this dashed line, notice that this does not cut off the bottom of the flagpole, right? It cuts off the flagpole at whatever height Timmy is. So how tall do we think Timmy is? Well, let's just assume that Timmy's maybe 5 feet tall. Okay, Timmy's 5 feet tall. So if Timmy's eyeballs are 5 feet above the ground, okay, 5 feet above the ground, how much of the flagpole is above his eyes? Right? What is the vertical distance from his eyes to the top of the flagpole? Well, it'd be 25 feet, right? Okay, so be careful about if something is this tall, do I know how tall the other person is? If you don't, then just don't worry about it and just assume that we're talking about angle of elevation from the ground. But if we're talking about angle of elevation from somebody's eyes, we have to sort of take away their height from the height of the other thing. Okay, so this is now 25 feet, right? And I'm looking for how far is Timmy from the bottom of the flagpole, right? What is the horizontal distance from Timmy away from that flagpole? So from Timmy to the bottom of the flagpole is going to be X. Okay, and so now I have to do some trigonometry. This is my problem. I need to solve for X. So based on my 54-degree angle, I think the 25 is the opposite side and the X is now the adjacent side, right? Because my straight line distance, I don't care about. I don't care how far Timmy's eyeballs are actually from the top of the flagpole. I want to know how far away is he from the bottom of the flagpole, right? How far away is he standing? So when I have the opposite leg and the adjacent leg and nothing about the hypotenuse, I need to use tangent. Okay, so what I do is I set up tangent of that 54-degree angle is equal to 25 over X. Okay, 25 over X. And again, I'm going to turn the tangent of 54 into a decimal, which is 1.376. 1.376 is equal to 25 over X. Put that over 1, and I solve now with my fish method. 25 times 1 divided by 1.376. 25 times 1 divided by 1.376. And I get 18.1686. So about 18.2. So the horizontal distance from Timmy to the flagpole is 18.2 feet. Okay, 18.2 feet. We found that, again, by reading our problem, drawing a picture, showing the angle of elevation, and solving. Okay, now it is important when you are doing these problems in your homework, I do want to see pictures. Okay, I'm going to make you draw pictures for any one where you are actually solving for x. Okay, there's a couple where they're just asking you, is this an angle of elevation or angle of depression, and they give you the picture. Okay, if they don't give you a picture, you have to draw one, and I want to see it, and I want to see the work, and that will make me very happy. Okay, if you have any questions about how angles of elevation or depression are used to draw pictures, or how to then take the triangles we've created and solve for distances, do please let me know. Reach out to me. I'd be happy to help. Otherwise, that's all I have for you right now, and we'll talk to you soon.